Hello dear students, all of you welcome to Vidyan classes. Today we will discuss some entrance level questions. Question number 1. If cos inverse 1 minus s square divided by 1 plus s square plus cos inverse 1 minus y square divided by 1 plus y square is equal to pi by 2, then which one of the following is correct? Cos inverse 1 minus s square divided by 1 plus s square plus cos inverse 1 minus y square divided by 1 plus y square is equal to pi by 2. It is taken as equation 1. Put x is equal to tan alpha, y is equal to tan beta. Equation 1 implies cos inverse 1 minus tan square alpha divided by 1 plus tan square alpha plus cos inverse 1 minus tan square beta divided by 1 plus tan square beta is equal to pi by 2, which implies 1 minus tan square alpha divided by 1 plus tan square alpha is equal to cos 2 alpha. It gives cos inverse cos 2 alpha and cos inverse it is cos 2 beta is equal to pi by 2. Cos inverse cos x is equal to x, that means 2 alpha plus 2 beta is equal to pi by 2, which implies alpha plus beta is equal to pi by 4. Clear? It is 2 alpha, it is 2 beta. Cos inverse cos x is equal to x if x belongs to close bracket 0 pi close bracket. What is alpha? Alpha is equal to tan inverse x, which implies alpha is equal to tan inverse x, beta is equal to tan inverse y is equal to pi by 4, which implies tan inverse x plus y divided by 1 minus xy is equal to pi by 4. Since xy less than 1, in this condition tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. Which implies tan inverse x plus y divided by 1 minus xy is equal to pi by 4, which is equal to tan inverse 1. Tan pi by 4 is equal to 1. Clear? X plus y, which implies x plus y divided by 1 minus xy is equal to 1, which implies x plus y is equal to 1 minus xy, which implies x plus y plus xy is equal to 1. Here tan inverse this is equal to tan inverse 1, so this is equal to 1, which implies x plus y plus xy is equal to 1, so the correct option is D. Clear? Okay. Next question number 2. The value of cos inverse 1 by root 2 into cos 9 pi by 10 minus sin 9 pi by 10 is equal to dash. Solution. Cos inverse 1 by root 2 cos 9 pi by 10 minus sin 9 pi by 10, which is same as cos inverse 1 by root 2 cos 9 pi divided by 10 minus 1 by root 2 sin 9 pi by 10, which is same as cos inverse cos pi by 4 is equal to cos 40 by 2 is equal to 1 by root 2. Cos 9 pi by 10 minus sin pi by 4 is 1 by root 2 into sin 9 pi by 10, which is same as cos inverse cos pi by 4 plus 9 pi by 10. Cos A plus B is equal to cos A into cos B minus sin A into sin B, which is equal to cos inverse cos 25 pi plus 18 pi, that is 23 pi, which is equal to cos inverse cos 2 pi minus 17 pi divided by 20. 45 minus 17 pi is equal to 23. Since (23 pi divided by 20) does not belongs to close bracket 0 pi close bracket. Since 23 pi divided 20 does not belongs to this set, so we can write this is the same as this, which is same as cos inverse every even pi is equivalent to 0, cos minus theta is equal to cos theta, that is cos 17 pi divided by 20, which is same as 17 pi divided by 20. Since cos inverse cos x is equal to x if x belongs to close bracket 0 pi. Here 17 pi by 20 belongs to close bracket 0 pi. Since 17 pi divided by 20 belongs to close bracket 0 pi close bracket, it gives cos inverse cos 17 pi divided by 20 gives 17 pi by 20 by this rule. So the correct option is D. Clear? Clear? Okay, note down. Question number 3. So that the function f so that close bracket minus half close bracket to close bracket minus pi by 2 pi by 2 close bracket b defined by fx is equal to sin inverse 3x minus 4s cube is 1 1 and on 2. Proof. We know that for x belongs to close bracket minus half close bracket fx is equal to y is equal to 3 sin inverse x, which is same as sin inverse 3x minus 4 s cube. In properties of inverse trigonometric function, we have proved for x belongs to close bracket minus half close bracket fx is equal to y is equal to 3 sin inverse x, which is same as sin inverse 3x minus 4 s cube. The function is defined from this set to this set. Fx is equal to sin inverse 3x minus 4 s cube. We have to prove the function defined by is bijective. That means 1 1 and on 2. Test for injective. That means 1 1. By the definition, for every x1 x2 belongs to the domain set, that is close bracket minus half close bracket fx is equal to fx1 fx1 is equal to fx2 implies this. Fx1 means fx is equal to 3 sin inverse x, fx1 is equal to 3 sin inverse x1, fx2 means 3 sin inverse x2, which implies this. Sin inverse x1 is equal to sin inverse x2. Sin inverse x is equal to sin inverse y, x is equal to y. That means x1 is equal to x2. For every x1, x2 belongs to the domain set, fx1 is equal to fx2 implies this x1 equal to x2. Therefore, the function defined by is 1 1. That means injective. Test for surjective. Test for surjective. That means on 2. Test for surjective. For every y that is equal to fx belongs to codomain set. That means minus pi by 2 close bracket. For every y belongs to close bracket minus pi by 2 implies s. What is y or fx? That is 3 sin inverse x belongs to close bracket minus pi by 2 For every y belongs to codomain set, that means x 3 sin inverse x belongs to close bracket minus pi by 2 close bracket. That implies sin inverse x belongs to close bracket minus pi by 6 plus pi by 6 close bracket, which implies x belongs to sin minus pi by 6 sin plus pi by 6. Sin inverse x belongs to this set, x belongs to sin minus pi by 6 sin pi by 6 implies x belongs to minus half close bracket minus half close bracket. Now we have for every y belongs to close bracket minus pi by 2 close bracket, there exists, it is the symbol of there exists x belongs to close bracket minus half so that y is equal to fx is equal to 3 sin inverse x. Y is equal to 3 sin inverse x. When y belongs to this set, x belongs to this set. It is the definition of surjective or onto. For every y belongs to codomain set, there exists x belongs to domain set, so that fx is equal to y. Taking y is equal to 3 sin inverse x, it is satisfies the definition of onto function. That means surjective. Therefore, implies the function defined by is onto or surjective. In case 1, we proved the function is 1. In case 2, we proved that the function is onto. Therefore, the function be defined by is 1 1 and on 2. Hence proved. Hence proved. The function defined by is the 1 1 and on 2, that means bijective. Clear? Okay. Next, question number 4. If sin inverse half plus cos inverse x is equal to, if sin inverse 1 by 5 plus cos inverse x is equal to 1, so that then find the value of x. Sin inverse 1 by 5 plus cos inverse x is equal to 1, which implies sin inverse 1 by 5 plus cos inverse x is equal to sin inverse 1. Sin inverse 1 is the radian angle which is equal to pi by 2. Sin inverse 1 is equal to pi by 2. Since sin pi by 2 is equal to 1, which implies sin inverse 1 by 5 is equal to pi by 2 minus cos inverse x, which is same as sin inverse x. Since sin inverse x plus cos inverse x is equal to pi by 2, if x belongs to close bracket minus 1 1 close bracket, sin inverse x is equal to sin inverse 1 by 5, implies x is equal to 1 by 5 is the answer. Easy question. Sin inverse this is equal to 1. This value is a sin inverse 1. Sin inverse 1 is equal to pi by 2. Sin inverse 1 by 5 is equal to pi by 2 minus cos inverse x. Pi by 2 minus cos inverse x is equal to x. Sin inverse x is equal to sin inverse 1 by 5. X is equal to 1 by 5. Clear? Okay, note down. Next, question number 5. Tan 3 tan inverse 1 by 5 minus pi by 4 is equal to dash. Solution. Tan 3 tan inverse 1 by 5 minus pi by 4. It is taken as star. Put tan inverse 1 by 5 is equal to alpha, which implies tan alpha is equal to 1 by 5. Star implies tan 3 alpha minus pi by 4. Tan A minus B is equal to tan A minus tan B divided by 1 plus tan A into tan B. A means 3 alpha, B pi by 4, which is same as tan 3 alpha minus 1 divided by 1 plus tan 3 alpha. Tan 3 alpha is equal to 3 tan alpha minus tan cube alpha divided by 1 minus 3 tan square alpha. It is the formula for tan 3 alpha, which is same as 3 into tan alpha is equal to 1 by 5. Tan cube alpha 1 by 125. 1 minus 3 into tan square alpha 1 by 25, which is same as 3 by alpha minus 1 divided by 125. 1 minus 3 by 25, which is same as 125 75 minus 1 whole divided by 22 divided by 25, which is same as 74 by 5 into 22, which is same as 74 divided by 37 divided by 55, which is same as 37 by 55. Tan 3 alpha is equal to 37 divided by 55 minus 1 whole divided by 1 plus 37 divided by 55, which is same as 37 minus 55 divided by 55 plus 37, which is same as minus 18 divided by 92, which is same as minus 9 by 46. Minus 9 by 46. The correct answer is none of these. Tan 3 tan inverse 1 by 5 minus 5 by 4 is equal to minus 9 by 46. So the correct option is D, that is none of these. Clear? Okay. Question number 6. Cos 2 cos inverse 1 by 5 plus sin inverse 1 by 5 is equal to dash. Cos 2 cos inverse 1 by 5 plus sin inverse 1 by 5, which is same as cos inverse 1 by 5 plus cos inverse 1 by 5 plus sin inverse 1 by 5. 2 cos inverse 1 by 5 can be written as cos inverse 1 by 5 plus cos inverse 1 by 5. Cos inverse 1 by 5 plus pi by 2. Since cos inverse x plus sin inverse x is equal to pi by 2, x belongs to close bracket minus 1 1. Here x is equal to 1 by 5 belongs to this set. This value is pi by 2. Sin inverse 1 by 5 plus cos inverse 1 by 5 is equal to pi by 2. Clear? Cos 90 plus theta is equal to minus sin theta. Theta means cos inverse 1 by 5, which is same as sin inverse square root of 1 minus 1 divided by 25. Cos inverse x is equal to sin inverse root of 1 minus s square if x greater than equal to 0, less than equal to 1. In properties, we have proved cos inverse x is equal to sin inverse this. Also, sin inverse x is equal to cos inverse root of 1 minus s square. Which is the same as square root of 24 divided by 5, which is equal to minus 2 root 6 divided by 5. So the correct option is A, that is minus 2 root 6 divided by 5. Clear? Okay, no doubt. Question number 7. The range of fx is equal to square root of sin inverse 2x minus pi by 6 is dash. Fx is equal to square root of sin inverse 2x minus pi by 6. Implies fx is exist if sin inverse 2x minus pi by 6 greater than equal to 0 and 2x greater than equal to minus 1 less than equal to plus 1. Fx is exist if these two conditions are satisfied, which implies sin inverse 2x greater than equal to pi by 6 and x greater than equal to 1 by minus 1 by 2 less than equal to half. It is taken as star. Sin inverse 2x greater than equal to sin inverse half, which implies 2x greater than equal to half. Since sin is an increasing function on close bracket minus pi by 2 close bracket, which implies x greater than equal to 1 by 4. It is taken as double star. Clear? the intersection of star and double star. That means common solution of a star and a double star implies this: x greater than equal to 1 by 4 less than equal to 1 by 2. X greater than equal to minus half less than equal to half and x greater than equal to 1 by 4. The intersection or common solution of a star and a double star is x greater than equal to 1 by 4 less than equal to 1 by 2. We have to find out the range. At x equal to 1 by 2, f is the maximum. F max is equal to square root of 2x is equal to 1 sin inverse 1 minus pi by 6, which is same as square root of pi by 2 minus pi by 6, which is equal to square root of 90 minus 30, that is 90 minus 30, which is equal to 60, square root of pi by 3. At x is equal to 1 by 4, f is minimum. F mean square root of sin inverse 2x is equal to half minus pi by 6, which is same as sin inverse half, that is equal to 30 pi by 6 minus of pi by 6 square root, which is same as 0. The minimum value is 0 and the maximum value is the square root of pi by 3. Therefore, the range of f, the range of f is equal to, the minimum value is 0 and the maximum value is root of pi by 3, close bracket. So the correct option is D. The minimum value is 0 and the maximum value is root of pi by 3. So the range of f, close bracket, 0 root of pi by 3. Clear? Okay. Next, if a cot inverse root of cos alpha plus tan inverse square root of cos alpha is equal to x, then sin x is equal to dash. Cot inverse x plus tan inverse x is equal to pi by 2 implies this: pi by 2 is equal to x. Since cot inverse x plus tan inverse x is equal to pi by 2, x belongs to set of real numbers. It is x, cot inverse x plus tan inverse x is equal to x. X is equal to pi by 2, sin x is equal to sin pi by 2, which is equal to 1. Then sin x is equal to dash. It is 1. So the correct option is C, that is 1. Clear? Okay. No doubt? Question number 9. If tan inverse x plus tan inverse y is equal to 4 pi by 5, then cot inverse x plus cot inverse y is equal to dash. Tan inverse x plus tan inverse y is equal to 4 pi by 5. Implies this tan inverse x is equal to pi by 2 minus cot inverse x. Tan inverse y is equal to pi by 2 minus cot inverse y is equal to 4 pi by 5. Since tan inverse x plus cot inverse x is equal to pi by 2, x belongs to set of real numbers, which implies pi by 2 plus pi by 2, that is pi minus cot inverse x cot inverse y is equal to 4 pi by 5. Pi by 2 plus pi by 2, that is pi, which implies cot inverse x plus cot inverse y is equal to pi minus 4 pi by 5, that is equal to pi by 5. Easy question. Cot inverse x plus cot inverse y is equal to pi by 5. So the correct option is B. Clear? Okay. Next, if sin inverse x less than cos inverse x, then which one is correct? Sin inverse x less than cos inverse x implies sin inverse x less than pi by 2 minus sin inverse x. Since sin inverse x plus cos inverse x is equal to pi by 2, x belongs to close bracket 1, 1, close bracket minus 1, 1 close bracket, which implies 2 sin inverse x less than pi by 2, which implies sin inverse x less than pi by 4, which implies sin inverse x greater than equal to minus pi by 2 less than pi by 4. Since sin inverse x greater than equal to minus pi by 2 less than equal to plus pi by 2, x belongs to close bracket minus 1, 1. Clear? Minus pi by 2 can be written as sin inverse minus 1. Sin inverse minus theta is equal to minus sin inverse theta. Sin inverse 1 is equal to pi by 2, so it is minus pi by 2. Less than equal to sin inverse x less than sin inverse 1 by root 2. Sin inverse minus 1 less than equal to sin inverse x less than sin inverse 1 by root 2, which implies x greater than equal to minus 1 less than 1 by root 2. Since sin is an increasing function, on close bracket minus pi by 2 close bracket. Since sin is an increasing function, we can write sin inverse x is equal to minus 1. Sin inverse x is equal to x. Sin inverse x is 1 by root 2. And sin is an increasing function. Clear? Sin inverse minus 1 equal to minus 1. Since sin inverse x is equal to x belongs to close bracket minus 1 minus 1 and 1 by root 2 belongs to this set. So we can write this. So the correct option is x greater than equal to minus 1 less than 1 by root 2. Very important entrance question. X greater than equal to minus 1 less than 1 by root 2. So the correct option is A. Clear? Next, question number 11. Tan inverse 1 by 3 plus tan inverse 1 by 7 plus tan inverse 1 by 13 dotted to infinity. Which one is correct? Tan inverse 1 by 3 plus tan inverse 1 by 7 plus tan inverse 1 by 13 plus dotted to infinity. Sum of infinite terms. Tan inverse 1 by 3 can be written as tan inverse 1 divided by 1 plus 1 plus 1 square. That is 3. Tan inverse 1 by 7 can be written as tan inverse 1 divided by 1 plus 2 plus 2 square. That is 1 by 7. Tan inverse 1 by 13 can be written as 1 divided by 1 plus 3 plus 3 square plus to infinity. Tan inverse 1 divided by 1 plus 1 plus 1 square plus tan inverse 1 divided by 1 plus 2 plus 2 square plus tan inverse 1 divided by 1 plus 3 plus 3 square plus dotted plus tan inverse 1 divided by 1 plus n plus n square. N tends to infinity. Addition of first n terms. N tends to infinity. It is the last term. N tends to infinity. Which is same as tan inverse 1 divided by 1 plus 1 plus 1 square plus tan inverse 1 divided by 1 plus 2 plus 2 square plus tan inverse 1 divided by 1 plus 3 plus 3 square plus dotted 1 can be written as tan inverse n plus 1 minus n divided by 1 plus n into n plus 1. Tan inverse x minus y divided by 1 plus xy. N tends to infinity. N tends to infinity. It is taken as star. tan inverse n plus 1 minus n divided by 1 plus n into n plus 1 is same as tan inverse n plus 1 minus tan inverse n. It is the nth term, n tends to infinity. Star implies s. Star implies s. Star implies s. For n is equal to 1. For n is equal to 1, it gives the first term. N is equal to 2, it gives the second term. N is equal to 3, it gives the third term. And n is equal to n, it gives the last term, that is infinity term. Star implies s. For n is equal to 1, tan inverse 2 minus tan inverse 1. For n is equal to 2, it gives the second term. Tan inverse 3 minus tan inverse. For n is equal to 1, tan inverse 2 minus tan inverse. For n is equal to 2, tan inverse 2 minus tan inverse 2. Plus n is equal to 3, tan inverse 4 minus tan inverse 3. Plus rotated the last term, tan inverse n plus 1 minus tan inverse n. N tends to infinity. Tan inverse 2 cancel. Tan inverse 3, tan inverse 3 cancel, which is same as tan inverse in first term, it gives minus tan inverse. In the last term, it gives tan inverse n plus 1. So it is tan inverse n plus 1 minus tan inverse 1. N tends to infinity, which is equal to tan inverse infinity minus pi by 4. Tan inverse 1 is equal to pi by 4. N tends to infinity, n plus 1 approaches to infinity. Tan inverse infinity is equal to pi by 2. Tan pi by 2 is infinity minus pi by 4, which is equal to pi by 4 is the answer. Clear? So the correct option is B. Once again, tan inverse 1 divided by 1 plus n into n square can be written as tan inverse n plus 1 minus n divided by 1 plus n into n plus 1. This is same as this. It is the nth term, n tends to infinity. For n is equal to 1, it gives the first term, n is equal to 2, it gives the second term, n is equal to 3, it gives the third term. But this is same as tan inverse n plus 1 minus tan inverse n, since tan inverse x minus tan inverse y is equal to tan inverse x minus y divided by 1 plus xy. For n is equal to 1, the first term is this. For n is equal to 2, the second term is this. For n is equal to 3, it is the third term. tan 2 cancel, tan 3 cancel. The last term gives tan inverse n plus 1 and the first term gives minus tan inverse n plus 1. Tan inverse 1 equal to pi by 4. For n tends to infinity, tan inverse n plus 1 is tan inverse infinity, which is same as pi by 2 minus pi by 4, that is pi by 4. So the correct option is B, that is pi by 4. Clear? Okay, note down.